Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this particular video, we will be talking about the pros and cons of this algorithm. See, in the previous two videos, we have understood that, what is the mathematical intuition behind this KNN algorithm. We have understood the distance metric concept as well, that how basically this algorithm is used to evaluate that k nearest neighbors, where this value of k is a hyperparameter, which is basically we need to find out via the algorithms that we have, right? Maybe grid search CV, randomized search CV, which we will discuss in a separate module altogether. Now the biggest question is ki, theek hai, this is the complete overall idea we have understood, but is there any disadvantage of this algorithm, or is there any use cases which we have in which definitely we can prefer KNN, and in other use cases we definitely don't prefer that? So in this video I will try to talk about in terms of, you can say, real industry per se, that at what scenarios this algorithm is majorly used, and what scenarios you should avoid using this algorithm, and what is the reason behind that. So without wasting any time, let's get started. So whenever we are talking about the pros and cons of this algorithm, let's first of all talk about pros, right? So you will be able to observe that whenever we are talking about the advantage, or I would say pros of this algorithm, the very first thing which I believe you also have observed, that this algorithm, which is KNN, it doesn't make any sort of assumptions. So it doesn't make any assumptions about the distribution of data, So be it any distribution of data, we can, apply this algorithm pretty well. Make sense? So that is important to understand, that it doesn't make any distribution of the data. For example, if you remember when we were discussing about linear regression, there was an assumption that the distribution of data should be linear in nature. Otherwise, we cannot apply linear regression. Same thing went for logistic regression as well. So in KNN, there is no as such limitation that we have, right? You can apply any kind of distribution, whether it be non-linear, whether it be linear, and definitely if it have to work fine, it will work. So KNN can be applied in any kind of distribution. That's the good thing. Second good thing is, in this particular algorithm, that you will observe that not much, I would say, extensive cost is required. So there will be a time cost, which is very less at the time of training. That is a good thing. So you will observe that when you are training your model, at the time of model training phase in your complete life cycle of machine learning project, you will observe that at any point of time, whenever you're applying the KNN algorithm, it is instantly giving you the results. Now I will talk about the major reason behind that as well. But yes, at the time of training specifically, I am saying it will be giving a less time cost at the time of training specifically we are talking about, right? This is the important thing which you have to understand. So two important things, or you can say two important advantages of this particular algorithm. First advantage is that there is no as such assumption. Second advantage is that at the time of training per se, the execution time is very much faster. It means the time required to train that model is very, very less. Makes sense, right? Now let's talk about the disadvantage, which is very, very important to understand. Or in other words, you can say cons of this algorithm. Okay? Cons, or I would suggest disadvantage. Anything you can refer. Disadvantage, right, of this particular algorithm. Now, whenever we are talking about cons, or whenever we are talking about disadvantage, the very first thing which you will heard, or you will see in most of the standard websites, or even in the standard books with respect to KNN, that it is a lazy learner. It is a lazy learner. Very, very important to understand. Even in interviews also, interviewer can ask from you that why KNN algorithm is called as a lazy learner. So the major reason behind that is that, as I told you, at the time of training itself, the time required to train the KNN algorithm is very, very less. Why is that? So let's try to understand this. See, what is happening is, in the KNN algorithm, when test data will come actually, then it will try to do the starting process. It will try to see the k nearest neighbors. It will check that, okay, what is the probability of having a positive class? What is the probability of having a negative class? But at what point of time? When the test data will come into picture. Means at the time of training, nothing is as such happening. Usually, for example, let's take an example of linear regression because you have already done that. If you remember in linear regression, when we are training our model, I told you in that particular video also that in a way, when you're saying I'm training my model, you're trying to learn, or your model is trying to learn the best parameters of MNC, right? So at the time of training, specifically I'm talking about in linear regression, because you have already have an in-depth understanding of that algorithm, right? We already have covered up as a very first algorithm in our courses linear regression. So if you will be able to observe, when I was saying that at any point of time when you are saying your model is training in the linear regression, it is trying to find out the optimal value of M and C. Optimal value means where the error is minimum. Where the error is minimum, that is where we have understood the complete concept of gradient descent, right? So at that point of time, we have understood that, okay, when model is training, it is taking so much time so that it will be able to reach to a global minima where the error is minimum. That is where we will be able to get the value of M and C. Make sense? Now, the same picture is not there in KNN. We don't have any specific parameters which we can train at the time of model training, and at the time of testing, we can use those parameter values to test the outcome, right? That's why it is called as a lazy learner, because at the time of prediction, it will take too much time. It will take too much time. Why is that so? Because at the time of prediction only, all the calculations will be starting. Calculations started at the time of prediction only, right? It will try to fetch the value of K. Accordingly, it will try to see that test data, what is the distance, Euclidean distance, maybe as a default parameter with respect to every actual data point that we have. Then it will take the value of K, for example, if you're talking about 3, so it will try to find out the probability of that accordingly and give us the final result. So that is why, because at the time of training, it is not doing that much huge task, and at the time of testing, it is trying to start everything from scratch. That's why the name is given as lazy learner. It's a lazy learner, that's why. Lazy means alsi, right? So it is not doing anything from the start, it is doing at the end when the prediction is happening. Second important thing, which is a part of, again, cones here, is to find out the optimal value of K. Because we don't know whether the value of K as 5 will be good, or 7 as good, or 3 as a good. So to find out the optimal value of K, right, will take a lot of time. If you will apply those techniques called as grid search CV or randomized search CV, which is a part of hyperparameter tuning. In the upcoming module, when we are talking about that specific module of hyperparameter, I'll show you that this much amount of time, maybe sometimes depending upon the kind of data and how many number of records we have, it can take hours and days also to give you a appropriate value. So basically that is again a bigger disadvantage of this algorithm, where it might take too much time to understand that what could be the optimal value of K that we should put depending upon what kind of data we are dealing with, right? So these two could be the disadvantages of KNN algorithm. One important thing which I want to mention before I'll close this particular part of the section is that because this is a lazy learner, now I hope everyone understands what is the meaning of that. That is why you will observe that whenever you will be having a huge amount of data, right, at that point of time, in practical terms, people usually avoid using this KNN algorithm. Because let's say if you will be having a huge data points, and because it is not doing anything as such in the training per se, it is everything doing at the prediction time. So you can understand that how much computational task it is and how much time it will take at the time of prediction to give us a result, whether it be of a classification task or it will be of a regression task. That is why usually people prefer this kind of algorithm when we will be having a smaller set of data points. So let's try to understand that where in terms of real part, the applications of this algorithm lies. First application is whenever you will be having a smaller data points. At that point of time, it would be great deal to use this algorithm, because be it any distribution, we can use this data. That's a good thing about this particular algorithm. So you can use that. It doesn't care that what kind of data distribution you have, right? Second interesting thing is that whenever you want to do a data imputation, what is the meaning of that? The simple literal meaning is, let's say you will be having null values available in your data, right? Null values available in your data in any of the feature you can consider. In that particular case, those null values, which particular value shall I impute in that place, shall I replace in that place of null, that can be also evaluated by KNN algorithm, because we will be having a limited set of data points, and it will internally we can apply that KNN algorithm to give us a better optimal value which could be replaced with that null value, right? That is one of the way which maybe in the upcoming sections of the course we will see data imputation widely used. Another application is, there is something called, as I told you in the last session, I believe, SMOT technique, which is a part of a oversampling, which is basically used to handle the imbalanced data which you already have seen in a healthcare based data. In that case, if you remember, we have applied a SMOT, right? If you will see the internal working of SMOT, so this is your today's task. After watching this video, check out the internal working of SMOT, right? There you will see, in order to generate the synthetic samples or artificial samples, it is again using the concept of KNN. So your task of today's video after this session is to check the, or you can say research about how SMOT works. Okay, this is your today's task. Fine. So do let me know what are the inferences you will be able to get after doing your own research. Maybe you can connect with me via mail or via LinkedIn. I'm available in both of the platforms. With this, let's try to understand that all these things are very, very important. What are the pros of any algorithm that we have, at what point of time we should go for which kind of algorithm. And I hope that you have understood this particular fact so far in a very amazing manner. So now I hope that you have understood clearly that what are the pros and cons of this KNN algorithm, and at what point of time we should go for this kind of algorithm. In the upcoming session, because in this session I have talked about something called as lazy learner, why it is called as a lazy learner, what is the major issue behind this brute force approach of KNN. Why I'm saying brute force approach, because this is the very first approach which researchers have found out algorithmically. After that, a lot many optimizations happened on top of this KNN, in which they tried to resolve the issue somehow in terms of that lazy learner part which I was talking about. So we will try to see that what other algorithms that we have in terms of optimization per se, which researchers have built upon KNN, right, in the upcoming video. So please stay tuned for that, and I'll see you all in the upcoming session. Bye bye everyone, and see ya.